So imagine I gave you this situation, okay? So a student who studies for 2 hours and only getting 50 marks. Another student who is actually studying for 5 hours and getting 80 marks. So what do you think if someone who will study for 7 hours, how many marks will he get? So can you find any dots, any relationship? You will probably just say yes. Maybe it could be 90. So congratulations, you just made a prediction, and guess what? Machine learning does basically the same. Just look at old examples, find a patterns, and uses that pattern to make a new prediction. But here's the interesting part. Sometimes the machine learning has to predict numbers, but sometimes it have to predict the category, like in the case of Google Gmail is to predict the mail is spam or not spam. So that's where we get regression, classification, and k nearest neighbor k, which is called as KNN. And don't worry, no scary mathematics today, just dot lines, examples, and little bit of brain damage. So what are we going to learn today? Today we're gonna understand what is regression, and it is used for predicting a number. What is classification, and is used to predict category, and what is k near neighbor. It's basically look at your nearest neighbor and copy their decision. So by the end of this video, whenever someone give you any machine learning problem, you wanna say like, oh, this is regression. No man, I got it. This is classification. Let me ask to the nearest neighbor. So let's start with regression. This is super simple. Suppose we have information about houses and we have two data. One is of house size and one is of house price. So for example, a small house is gonna cost you 30,000, and maybe a medium house is gonna cost you 50,000, or maybe a big house is gonna cost you the 80,000. So now put those in graphs. Suppose house sizes goes here, like this x-axis. Suppose this is the house prices, and this y-axis is the house sizes. So when the sizes is increasing and along with the prices increasing, you can see here, and suddenly we have bunch of dots as well. Now if I ask you, can we find any pattern here? And yes, the bigger the house is getting, the bigger generally the higher the prices are. So what does the machine learning do? It basically tries to draw a line between these points, and so this is called as a regression line. So this line basically saying, based on what I have ever seen before, is the general trend. And now comes to the fun part. Let's say someone gave you a new house which have size of 2000, which is called as input 2000 square feet, okay? But we don't have the price data belonging to the 2000 square feet. So the model look at the trend line. Let's say here we have a trend line, and say probably it will be around the 70 lakh. Boom, that's called regression, because it can extend it and predict the prices according to your according to your input. So but you wanna say how the computer gonna where to put this line, because this line will have the right place of this, but it's not at its right place. So how it's gonna calculate it? So there is a mean square error, okay? So the computer basically tries a different line. Suppose this one is basically terrible, and if I adjust the point in the middle of this looks better. If I adjust the slope, oh, this one is pretty good, the trend. So the computer sick looking for the line and with the smallest error. Like you can see, if we align with this, the mean squared error have been decreased. That's what is happening. So what is it? Basically, what is this error? Imagine the actual house prices is 70 lakh, okay? But our model is predicting it's 60 lakh. So we made a mistake of 10 lakh. The distance between the actual value and the predicted value is basically in our error. So this is actually what we try to minimize in this model. In regression, want that error to be smaller as possible. So here's the part comes the part of MSE. Don't panic, guys, you might hear something called this for the first time, but it's just a fancy name to scare you. The basic idea is how wrong are my prediction on average. Okay, the computer actually calculates the square, this is called mean square, and the average them. So why they actually square them? You might got that question as well. Because a big mistake should hurt more than a tiny mistake. For example, being wrong by 1 lakh is okay, but being wrong by 50 lakh, bro, what are you doing? So big error get punished more heavily, man. And just remember this one thing: regression is equal to predicting a number only. Example, we have house prices, we can predict temperature of anything, we can predict the working professional salary, even though car prices, property prices, delivery time, sales, stock market prices. You can implement it to predict next year sales, next year financial data as well. So if the answer looks like anything like that, you will be anything like predicting, you will be sure that probably you are dealing with the regression. Okay, now let's change the game. Suppose Gmail receive an email, the system has to answer, is this the spam or is this not a spam? So that's where this classification comes in. It's basically used to predict whether the thing is belong to category A or category B. Imagine I give the computer thousands of pictures, and on the thousand of data there is some pictures of cats and there is some pictures of dog. So basically I am training my computer on dogs and cat images only. Then I show it a new picture of a dog which is maybe belonging to a new breed which my computer never seen, and ask them what is this. Then do you know what model gonna say? It's gonna surely say it's a dog. That's called classification because we're choosing between categories. And if I talk about the important thing in it, the major core concept is the decision boundary. So now let's look at our graph. We have blue dots and we have pink dots, and our job is to separate them. Now if I talk about the accuracy of separation is only 95%, and there is everything on this side of blue and everything on this side of pink. That is basically what it's saying. If you are on this side, I think you are blue. If you are on this side, think you are pink. So based on that, we're gonna move the lines. like for the position, maybe here, and we're gonna drag. This is 95%. That's a mistake. So we're gonna move it again. Better. This is 100% accuracy. So model is trying to find the boundary that correctly separate the group. And what is about this accuracy? So suppose we have 100 students and our model correctly predict 90, then we will get 90% accuracy, simple. But we have 90 correct and 10 wrong. No PhD required, man. So what's the important difference between these? This is one of the most important concepts in the whole video. Regression cares about how far away my prediction was, and classification care about did I put you in the correct category or not. Like here we have two categories, blue and pinks only. For example, actually regression, suppose we have a prediction of 100 rupees and another prediction is about 120 rupees, but the actual answer is only 90. So the regression will say prediction of 900 will be much better because it's the closest one. But the classification is different. Is suppose the actual category is dog and another category is cat, and our correct answer is dog, and our model is giving cat, then it's absolutely wrong. There is no any close sorts. So classification doesn't care about where you are slightly wrong or extremely wrong. You are simply right or maybe wrong. So remember, classification is about predicting a category. Suppose in Gmail we predict it's a spam or it's not an spam mail. And I had already give you an example of cat and dog. Suppose in banking you are applying for a loan, you can make the system to approve it or reject it. So it will be based on classification. Suppose in medical industry, doctor is checking you have diabetes or not. If we talk about the sentiment, you can recognize people are happy or sad, and people are doing fraud or not fraud. So if the answer is in label, classification comes to your mind first. So now we are gonna meet the weirdest kid of machine learning. His name is KNN, K nearest neighbor, and honestly this algorithm has very simple philosophy. It basically says, tell me who your neighbors are and I'll tell you what you are probably are. So imagine this, you are new in college, you walk into classroom, you don't know anyone, you want to know which group I'm probably going to hang out with. You probably look around and the 5 students who are sitting closest to you are blue, 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 pink, pink. Means 3 blue and 2 pinks. So you probably think, okay, probably I'm gonna go with the blue. That's called just a performing KNN. So what is K mean in KNN? So K is equal to how many neighbors should I ask. Suppose K is, in this example we have K is equal to 5, so we're gonna ask closest 5 point. If we will have say 3, then it will gonna connect only gonna ask to only 3 neighbors. And if we will have the 2 only, then it's gonna ask with the 2. In this case basically pink, which is the majority wins. Okay, so if we put the K is equal to 1, now we only ask one neighbor. So whoever is closest to decide everything. That's the powerful but dangerous. Because what if that one point is weird, act as outlier? So one of the strange point can completely change our prediction. Now let's increase the K. Let's say we have maybe 15 neighbors. asking many more neighbors. So the decision become more stable. But there is another problem. If we ask way too many people, we might start including people who are nowhere near us. It's like asking, should I eat pizza, and then taking advice from your best friend, your neighbor, your teacher, your uncle, your dentist, maybe random guy on Instagram at some point. Too many opinions become a problem. Cool thing about KNN doesn't really build complicated equations like some other algorithm. So it basically remembers the training data. Then when a new point comes, okay, who are your closest neighbor? And it checks them. Then why the KNN is incredibly easy to understand, but there is a catch. Imagine you have 10 points. Easy, 100 points. Still okay. If we have 10,000 points, suppose we have million points. Now imagine checking a huge numbers of points every time a new prediction arrives. That can become expensive and slow. So KNN is simple, but it doesn't always scale nicely. Okay, to any massive data sets. So KNN also do regression. It can do it. And here's another cool thing. KNN isn't only for categories. Suppose for your neighbor have house prices 40,000, 45,000, anything like it. Instead of voting, so we can simply take the average and KN classification majority the vote and average the major. Same neighborhood, different decisions. Pretty cool, right? Yeah. So whenever you get any ML problem, don't immediately start writing the Python. Don't just open the Jupyter notebook. Don't import 50 kinds of library. Just first ask only one thing. Am I predicting a number or a category? If it's a number, think for going for a regression, and if it's a category, then think for the classification model. Okay, so that's your first mental map of machine learning, and I'm gonna put the link of this page so you can get hands of experience about this. You'll find it in description. Don't worry about it. See you guys.